Scientific notation, concept 2, translating standard notation to scientific notation. So in the last video we looked at taking a scientific notation number and turning it into standard notation. Now we're going to do the opposite, but before we do, I want to make sure that we go through and we understand exactly what scientific notation is and what the form should look like every time. Okay, you're always going to have times 10. Okay, and that 10 will always have an exponent on it. All right, that exponent might be 1. Okay, but it'll still have some exponent on it. The number that'll change a lot, well, the exponent will change, but this number, the first one that you're multiplying by 10, is going to change. Now, the one thing about that won't change is that you will only ever have one number to the left of the decimal point. And you will always have a number to the left of the decimal point, and it should never be 0. Okay? If I turn this into 0.324 times 10 to the 4th, that looks pretty similar, right? And when I do the math, it would actually come out to the same number, but that would be an incorrect scientific notation. Okay? Scientific notation has to have one value between 1 and 10 to the left of the decimal. Okay? And it can't be 10. If it was 10, you'd just move the decimal over and have it be 1. All right? So keep in mind when you're doing this, you always have one number, one place value to the left of your decimal point. Okay. So when we are doing this, changing standard notation numbers into scientific notation, the first thing you're going to do is find your decimal point, and then you're going to move that so that your number, right now this is 123,400,000, so that your number becomes a number between 1 and 10. All right, so I'm going to go over once, twice, 3, 4, 5, 6, 7, 8, and now I put my decimal place because I have a number 1.234, and that is between 1 and 10. Okay, then I'm going to rewrite just those numbers. I can drop all those zeros. So I have 1.234 times 10. All right, that's the same all the time. You put that times 10. And then however many places you went over to the left, you're going to have a positive exponent. So 1, 2, 3, 4, 5, 6, 7, 8. 1.234 times 10 to the 8th. Okay? You can also remember if your number started out big, you're going to have a positive exponent because you're going to need to multiply this small number times a big number in order to get it back up to its original size. Okay, if we look at the other kind, now we've got a really small number. Because it's a decimal, because I know I'm going to have to move my decimal place to the right, I know that when I change this to a number between 1 and 10, I'm going to have to multiply it by a very small number, okay, or a negative exponent. So 1, 2, 3, 4, 3.01, that's between 1 and 10. So I have 3.01 times 10, and I'm raising that to the 1, 2, 3, 4 because I moved it to the right, because it started off as a small number, a decimal. I'm going to have to multiply this larger number, because this one is now larger than your old number, by a negative exponent. Okay. The idea is this is the same number as this, just written out differently. Okay. It's pretty easy to make mistakes and end up having what was 0.000301, and when you turn it into scientific notation, it becomes like 301,000 or something like that. Okay, so you do need to watch your exponent and your sign on your exponent.